So you know already geology and outline for the problems we are facing studying the Ediacaran succession on the Digarmul Peninsula, and I will concentrate on one particular part of the succession from the lowermost part, and just to recall you again about the story about the diamictites and glaciations in Scandinavia. So we have major portion of exposure with two diamictites in the northern part of Scandinavia and the same in Oslo area, but there are as well dismembered successions containing diamictites all along the Caledonian front. So consistently we see two layers of diamictites, and the discussion is about their age. When the diamictites were recognized and studied, it was considered as kind of, you know, local Varangerian type of glaciation and diamictites, and later on it was interpreted that the upper diamictite is time equivalent to Marinoan. Then later on it was considered that it is the age of Gasquiers, and now we are coming back to possibly reinterpretation that it might be Marinoan. Anyway, the strata which we are going to study is on Digarmul Peninsula, and this is part of the area of the Varangerian Peninsula where we have great exposure of the Neoproterozoic and then Cambrian and rocks. So this is the area. And the succession. There is no problem with the recognition of the transition from Ediacaran to Cambrian strata at the base of the Breivik Formation. Those color bands are showing the diamictites, Mortensnes and Smallfjord. Between both sections, we have 200 or 400 meters of the shales. There are few interbeds of carbonates, and those were used by Halverson and others to use for the chemostratigraphic correlation. However, those carbonate rocks are very minimal layers, and I wouldn't really rely on the signatures, carbon signatures from those layers. So I would prefer rather to think about the new isotopic dating of the swarms of dikes which are cutting with the cross-cutting relationships, those both diamictites in central part of Scandinavia, and the age which was obtained by uranium-lead dating is 596 million years. If we accept this age, this would suggest that the upper diamictite, Mortensnes, is definitely not equivalent to the Gasquiers age, and it should be Marinoan age. But we are now interested in the succession which is just above the diamictite and below the Cambrian, and I will concentrate on this lowermost part because the fossils I'm going to present you are collected from this succession. Anyway, the entire succession between Cambrian and upper diamictite is around 530 meters thick, siliciclastic rocks. We have the appearance of those earliest tubular fossils just around 50 meters above the upper diamictite. Then sequence interval containing Ediacara type body fossils with some discs coming up to the lower part, what Seren was just reporting, and then in the uppermost part we have appearance of trace fossils, organically preserved tubular fossils, Vendotenids, and then after small shelly fossils, which are typical for Cambrian. So let's have a look now at the succession. This is part of the succession attributed to the inner earth member, and we have two shallowing upward sequences in this succession. Excuse me. The interpretation of the environments is that the mudstones and interbeds of sandstones were deposited in shallow marine offshore environments, and in some portions perhaps within the tidal environments. those tubes, which I am going to show you, are just from the beds over here. First look, there are structures like those shown here, which are circular in cross-section. They are tubular, they have the same diameter across their length, they are preserved within those are the, this is the part of the bed, this is the structure. Interesting part is that those structures, tubular structures, have the same mineralogy as the surrounding bedrock or the layers in which they are preserved. There is no any differentiation. However, when we look at some portions, those cylindrical structures, which I believe may show actually the body fossils, they may have some kind of segmentation or annulation, and I am not certain. This is just a breakage of the tube, but in some portions we see some grooves or layers that may suggest that those fossils were segmented. Another type and shape of fossils from this layer are typically tubular. We see that this is the thickness of the wall. Inside there is empty lumen. And again, the construction of this tube is just made of siliceous minerals, and that's all what we may say. Anyway, if we accept that the dating 596 of the dikes gives us the idea of the minimum age for the upper tillite, and those fossils derive from the stratigraphic level around 50 meters above the tillite, this could be simply estimated or just suggested that we are looking at the succession perhaps around this age, 630 or 25, anyway, lowermost Ediacaran. Another type of structures which may be, is it a concretion or is it a trace fossils? Looking at this specimen, this is the embedding rock, this is the structure, rounded at one end, broken at the other, and presumably of the same diameter across the length. This is another type, tubular or cylindrical, tapering at the end, or perhaps this fragment of the embedding rock covers still continuous cylindrical part. So is it pinching out, or is it just not showing the real end of the fossil? If we look at this morphotype, perhaps it may recall morphologically Paleoficus type burrows, which were infilled by sediments, and if those structures are actually trace fossils, not just concretions or some sedimentary structure which would be abiotic, we would have, you know, very large, several centimeters in length and 1 centimeter or few millimeters across the diameter trace fossils. However, the much better and convincing evidence that we have actually metazoan or multicellular organisms preserved, this is the tubular fossil with some kind of grooves on the surface showing actually segmentation or compartments. We see very clearly consistent thickness of the wall and lumen inside. Now, I interpreted or preliminary called that it is agglutinated tube because the material constructing the tube is identical in mineralogy as the embedding rock, and this may be showing that actually we see the agglutinated tubular fossil, which is constructed of aluminosilicate minerals, exactly the same as we see in the bedrock. This is the same specimen shown in the scanning electron images, so we see clearly those grooves. This is the surrounding bedrock, and this one is the opposite side to the one which we see here, and from the upper view we see the consistent thickness on the wall. But what is very important is that the chamber which would be just defined by this groove, has some kind of semiseptum. So it is not just empty space throughout the tube, it has kind of septation or hemiseptation between those portions. And of course the elemental composition is shown here, that it is the same or very similar to the surrounding bedrock. Now, with this fossil, we have variety of tubular extending fossils. And again, if we accept that this fossil shows us metazoan-like or animal-like tubular organism, which was living inside the tube, which was agglutinated, so we may look at the bending sessile organism, and of course it is very difficult to make sense from this simple morphology what kind of organism it was, but it could be perhaps, very commonly saying, worm-like tube. What is important, however, is this early age of the occurrence of those fossils, and in fact this may represent the earliest metazoans which were producing agglutinated tubes or siliceous tubes, like in those conical shaped, so it would be just the first stage. Then 50 million years older and upper 100 meters or 200 meters above the occurrence of those tubular fossils, those are the typical Ediacara type soft-bodied compressions, which Seren was showing in extent. So in fact, if we accept that those fossils appear around 575, as it is so well documented in Newfoundland, we may observe the second evolutionary stage of appearance of this kind of morphologically complex organisms. And one interesting feature is that whenever we look across all the entire world for those fossils, we don't see preservation of any organic material associated with those imprints. I believe that there was one record by Dima Grajdankin from Siberia that there were small portions preserved or associated with those fossils, but as in a general rule, those Ediacara type compression fossils are just, shadows on the sand or mudstone, no organic matter. My understanding would be that perhaps it shows us that they were made of labile biopolymers, so therefore they are not preserved. And again, they were not preserved, they were unknown from the point of view of geochemistry, but prevented those organisms to be really preserved organically. So looking at the next step or next set of fossils, now we are looking at the uppermost of Ediacaran, and we have of course Sabellidites, which is a tubular fossil fully organically preserved, but it is not the only one, because we have the same kind of organic preservation in Corumbella and probably in Conotubus. But what is diagnostic and clearly shown, we see very robust construction of a tube with ridges, and it is so robust and so resistant that of course we can very easily extract this specimen by dissolving the rock by hydrofluoric acid, so the polymers are resistant. Even more, when you see here, we peel off the specimen from the surface, and it is what is remaining is kind of compression or imprints after the tube is removed. This is a small fragment still remaining. Looking at the scanning images, we see that the tube is rigid, it was firm, it is breaking of course, but still preserve elegantly the shape. And if we look at the high magnification, the construction of the wall made of organic matter is shown here by a line parallel to each other nanoscale fibers, which are in shape of, just tubes, but very small diameter, And this kind of ultrastructure and way of how those fibers are aligned, we see something like that in present-day annelids, pogonophorans, vestimentiferans, and those are made of chitin. We did as well chemical analysis and Raman spectroscopy on the organic matter within those tubes, and it looks like being chitin. However, this is just not finished work, so we are doing more analysis using different kind of biogeochemical methods to prove or disprove the chitin composition of the tube. Now, those are individual fibers shown in very high magnification from the wall of the tube, and they are in the scale of 100 to 100 nanometers in diameter, so they are really small. Anyway, the conclusion is that those tubular organically preserved fossils, like Sabellidites, were made of refractory biopolymer and chitin, and of course, due to this, they are so elegantly preserved. And this is very sharp contrast to all the complex, morphologically large in size, all those Ediacara type biota known only from the compressions. So I believe, or it could be something that in fact we are looking at the very novel evolutionary biosynthesis of refractory polymers, chitin group or a collagen group, and this will be seen as well in dismembered fragments of sclerites, which are preserved in the same intervals or the same age in very many places, and those look like, fragments of metazoans, which are so well known, and sclerites so well known in the Cambrian period. So in fact, perhaps this biochemical invention or revolution or in organic synthesis, and then at the same time biomineralization must be perhaps a signal in the evolution of the multicellular or metazoan type of organisms. And this is recorded in the terminal Ediacaran, perhaps last 10 million of years of the Ediacaran, and of course it continued in Phanerozoic. One interesting point as well is that production or synthesis of refractory biopolymers and then biomineralization, so elegantly seen in the Ediacaran, was going on for a long time since Mesoproterozoic among the protists or single-cell biota. And what I mean is that organically preserved single-cell organisms, which are just generally called accretars, are very well known, and they have produced, of course, resistant biopolymers, which are again in very general term referred to sporopollenin-like or algae-like groups, and of course cyanobacteria produce as well resistant biopolymers. And this kind of invention of the resistant polymers among multicellular and metazoan organisms happened just in the end of the Ediacaran. So if we look again at the succession on the Digarmu Peninsula, this is the stratigraphic level of appearance of those tubular and agglutinated fossils and presumably trace fossils. This is the level of the appearance of those complex morphologically soft-bodied imprinted organisms typical of the Ediacaran, and then after we have appearance of Sabellidites, and then later and of course association of trace fossils typical for the Cambrian, and above small shelly fossils and later trilobites. So in fact, when we look at this succession above the upper tillite, we perhaps may see biotic event and evolutionary stage one, which I called somewhere here, the appearance of complex metazoans over here, and then the uppermost part, Sabellidites and other tubular organisms in the topmost of the Ediacaran. So again, the question is, and we are waiting for the more extensive publication of this isotopic dating on the dikes cutting both diamictites, to be certain what kind of age is really the beginning of the succession shown here, but I believe that it may be just correlated, the upper diamictite correlated with the Marinoan, and then entire Ediacaran succession shown here with those 3 remarkable events in the appearance of organisms, which we have seen ago. So I believe that would be all, and this is just the site from the life on the Digarmul Peninsula. This is from old and first excursion during which the Ediacaran type metazoans were discovered, and this is the end of the road, Warangerian Peninsula and then Digarmul Peninsula seen on the horizon. There is permanent days, so happy mornings and a lot of work. We were fed very well on the fresh salmon, which was fished by our fisherman who was sailing us all along the fjord to different successions. But sometimes life was not so easy and so pleasant, because when the gale came there, you know, your tent is blown out, you don't like to be there. And there was one night where we were stranded on the beach because our master of the, or captain of the boat refused to sail across the fjord back to the camp because it was too dangerous. So we were stranded on the beach all along the old wrecks of the boats, and this is a sleeping body of Jack Farmer who was with us. So that was the life there. Thank you very much.
Thank you, Magdalena.